Good afternoon. Today we are going to continue into our lessons on ratios. You'll be learning about equivalent ratios. Grab you a sheet of paper, pencil. You are required to take notes, do example problems, and then complete a problem to bring into class with you tomorrow. So get your materials ready and let's get started. Remember, anytime you can stop this video, rewind it, pause it, fast forward it, whatever you need to do. So, I can statements. I can develop initiative understanding of equivalent ratios by using type diagrams to explore possible quantities of each part when given the part-to-part ratio. I can use type diagrams to solve problems when the part-to-part ratio is given and the value of one of the quantities is given. I can formalize the definition of equivalent ratios. Two ratios, A to B and C to D, are equivalent ratios if there is a positive number C, such as C equals C times A and D equals C times B. I can relate the positive number C in the description of equivalent ratios to the type diagram I have been using to find equivalent ratios. Things to include in your notes is information about equivalent ratios, examples, and type diagram, which is also examples and what a type diagram actually is. Equivalent ratios. If two ratios have the same value when simplified, then they are called equivalent ratios. Equivalent ratios can be obtained by multiplying or dividing both sides by the same non-zero number. For instance, remember when we was doing equivalent fractions? We would have to multiply or divide the numerator and denominator by the same number to get an equivalent fraction. For example, 5 6 equals 10 12. These are equivalent because I multiply my numerator by 2, which was 5 times 2 to get 10, and then I multiplied my denominator, 6, by 2 to get 12. The same rules apply to finding equivalent ratios. Whatever I multiply or divide one number by, I have to do the same to the other number. So let's try some. Write an equivalent ratio for each of the ratios listed below. Number 1, 2 to 5, number 2, 7 to 3, number 3, 4 to 20, and number 4, 15 to 9. Please pause video while finding equivalent ratios. Some possible answers for each of the four ratios. If I'm looking at number 1, I could say that I'm going to multiply both numbers by 2 to get an equivalent ratio. 2 times 2 gives me 4. And then 5 times 2 gives me 10. So 4 to 10 is an equivalent ratio of 2 to 5. Look at number 2, 7 to 3. I can say I'm going to multiply both of these numbers by 3. 7 times 3 gives me 21. And 3 times 3 gives me 9. So 21 to 9 is an equivalent ratio of 7 to 3. Looking at number 3, I'm going to take a little bit of a different approach. I'm going to divide both numbers. I can divide both numbers by 4. So if I take 4 divided by 4, I get 1. And 20 divided by 4, I get 5. Same thing with number 4. I'm going to divide both numbers by 3. So 15 divided by 3 gives me 5. And 9 divided by 3 gives me 3. So 5 to 3 is an equivalent ratio of 15 to 9. These are just one of many equivalent ratios that could have been written for the given ratios. For example, on number 3, instead of dividing the numbers, I could have multiplied both numbers by, let's say, 2. So 4 times 2 gives me 8. And 20 times 2 gives me 40. 8 to 40 is also an equivalent ratio of 4 to 20. Now let's use what you know about ratios to solve the following. Write the ratio 15 to 25 in simplest form. Write the ratio 4 to 8 in simplest form. Write the ratio 8 to 64 in simplest form. And write the ratio 14 to 21 in simplest form. Pause video to complete. Answers. Check to see if you is correct. The ratio 15 to 25 in simplest form, I could divide both numbers by 5 to get 15 divided by 5 is 3, and 25 divided by 5 is 5. So 3/5 is the simplest form, or 3 to 5 is the simplest form of 15 to 25, the ratio. If I write the ratio of 4 to 8 in simplest form, I could divide both numbers by its greatest common factor, which is 4, to get 1. And 8 divided by 4 gives me 2. So 1 to 2 is simplest form for the ratio of 4 to 8. And write the ratio of 8 to 64 in simplest form. Again, I use my greatest common factor of 8, and I divide 8 by 8 to get 1, and 64 by 8 to get 8. So 1 to 8 is simplest form for the ratio of 8 to 64. And then the ratio of 14 to 21 in simplest form, I find the greatest common factor, which is 7. 14 divided by 7 gives me 2. And then 21 divided by 7 gives me 3. So the ratio of 14 to 21 in simplest form is 2 to 3. So now we're going to try some reading problems. Let's use what we know to solve the following problems. Miss Lachi's recipe for salad dressing uses a ratio of 1 part olive oil to 2 parts vinegar. If she uses 3 cups olive oil, how much vinegar will she need? And then your second problem says marks grade areas as follow: reading 88, math 92, science 96, social studies 90, and language arts 94. Which classes are compared by the ratio 94 to 90? Write them as a ratio. Pause video to solve. Alright, so looking at our first problem, Miss Lachi's recipe for salad dressing uses a ratio of 1 part olive oil to 2 parts vinegar. I can set up my first ratio with this information. 1 part olive oil to 2 parts vinegar. Now, if she uses 3 cups olive oil, this is helping me to set up my other ratio. And we want to know how much vinegar she is going to need. So now, I can look and see how I can use equivalent ratios to help me solve this problem. If I know 1 times 3 gets me to 3, then I can also take 2 times 3 to get me to how much vinegar I will need. So, if I had 1 to 2 equals 3 to 6. So, I will need 6 cups of vinegar to go with the 3 cups of olive oil. Now, marks grade area as follows: reading 88, math 92, science 96, social studies 90, and language arts 94. Want to know which classes compared by the ratio 94 to 90. So if I'm looking back up at them, I see that language arts is 94 and social studies is 90. So writing this as a ratio, I get language arts to social studies. Type diagrams, which is a review from a previous lesson. Type diagrams, a drawing that looks like a segment of tape used to illustrate number relationships, also known as a strip diagram, bar model, fraction strip, or length model. Suppose the ratio of the number of boys to the number of girls on a team is 3 to 2. Below is a tape diagram to represent this ratio. So I see I have 3 pieces of tape to represent my 3. So each of them represents 1. And then I have 2 pieces of tape to represent my 2. 3 to 2. We can also use tape diagrams to represent equivalent ratios. If I'm looking at these ratios, I see that 2 to 3, 6 to 9, and 12 to 18 are all equivalent ratios. In my ratio 2 to 3, my tape diagrams, my pieces of tape are representing 1. To show the 2 to 3 ratio. Now with equivalent ratios, my size of my tape diagram is not going to change. I'm going to still have the same amount or the same sizes of tape. So in this case, 6 to 9, I still only have 2 pieces of tape to represent the 6 and 3 pieces to represent the 9. So if I'm looking at this, I see that 2 pieces to represent 6. So each piece, if I take and divide 6 by 2, I would get 3. So each piece is representing 3. And if I'm doing that to one number, I have to do it to the other. So if I divided 9 by 3, which is what my tape diagram is showing me, I would get that each piece represents 3. However, I could have also looked back at 2 to 3 and seen that I would multiply 2 times 3 to get to 6 and 3 times 3 to get to 9. Looking at 12 to 18, I can see that 2 times 6 will get me to 12, so each piece represents 6. And then 3 times 6 gets me to 18. So in this ratio, each of my pieces of tape represents 6 to demonstrate the ratio of 12 to 18. Alright, so let's try one on your own. Mason and Laney ran laps to train for a long distance running team. The ratio of the number of laps Mason ran to the number of laps Laney ran was 2 to 3. If Mason ran 4 miles, how far did Laney run? Draw a tape diagram to demonstrate how you found the answer. If Laney ran 930 meters, how far did Mason run? Draw a tape diagram to demonstrate how you found the answer. What ratio can we say are equivalent to 2 to 3? Pause the video until you have answered these questions. So now let's take a look at them. Starting out, we see that the ratio of number of laps Mason ran to the number of laps Laney ran was 2 to 3. So my first tape diagram, each piece of tape is actually representing 1. So now if I look at A part, if Mason runs 4 miles, how far did Laney run? Draw a tape diagram to demonstrate how you found the answer. So I'm just using my equivalent ratios. I still have the same amount of tape. So if Mason ran 4 miles, I have to split these 2 pieces of tape among the 4. So 4 divided by 2 actually gets me to 2. So each tape has to represent 2. So now I have a ratio of 4 to 6. Now if Laney ran 930 meters, how far did Mason run? If I'm looking at my tape to demonstrate Laney's run, which is 3 pieces, I'd have to divide 930 by 3 to get the 310. So each piece is representing 310. So if Laney's each piece represents 310, then Mason's also represent 310. So my ratio here would be 620 to 930. So the ratios that we can say they're equivalent to 2/3 are 4 to 6 and 620 to 930. Have ready for class. Josie took a long multiple choice end of the year vocabulary test. The ratio of the number of problems Josie got correct to the number of problems Josie got incorrect to the number of problems she got correct is 2 to 9. A. If Josie missed 8 questions, how many did she get correct? Draw a tape diagram to demonstrate how you found the answer. B. If Josie missed 20 questions, how many did she get correct? Draw a tape diagram to demonstrate how you found the answer. C. What ratio can we say are equivalent to 9? And D. Come up with another possible ratio of the number Josie got incorrect to the number she got correct. E. How did you find the numbers? F. Describe how to create equivalent ratios. Just a little hint. You might want to go back to the first part of your problem, the informational part, and start by creating a tape diagram to represent 2 to 9. Have it ready for tomorrow. Lesson summary. 2 ratios, A to B and C to D, are equivalent ratios if there's a positive number C, such as C equals C times A and D equals C times B. Ratios are equivalent if there's a positive number that can be multiplied by both quantities in one ratio to equal the corresponding quantities in the second ratio. This description can be used to determine whether 2 ratios are equivalent. Hope you all have a great evening, and I will see you tomorrow.